So question number 17. Now onwards, all questions are important. Okay. So here you are given a square with each side measure equals to 18 centimeter, and you are asked to form a box by cutting a square from each corner and folding up the flaps to form a box. Okay. What should be the side of each square to be cut off such that the volume of the box is maximum? Okay, so you want to maximize the volume. So suppose here is a square. There's square where measure of each side you are given 18 here, 18 centimeter. This is also 18 centimeter. Okay, so let's write here. We cut x centimeter from each corner. Let x centimeter you are going to cut from x centimeter, cut off from each corner here. Okay, so we are going to cut this x and this x. Here also x, here also x. This is x, this is also x. This is x, this is also x. So now when you fold this up, then this become height. Now what about this, for example, length, that is 18 minus 2x. So therefore here you can write the height will be x. Height equals to x. We cut this and we fold up, so height will be x. You can write next, that is, what about the next, length. Length or breadth. Length, what will be the length? For example, this is length. It will be 18 minus x minus 2x. And what about here breadth? It would be again 18 minus 2x. Fine? Correct? We cut this portion and we fold up, so this become height. This length and breadth would be here only. You are cutting this and you are folding up. This much we are going to drop. This portion. This much we are going to drop here. This much we are going to drop. This much we are going to drop. And you will fold up, so this become height. Okay, if I show you here, like see, suppose this is a square. I'll cut x from here and x from here. Okay, and what I'll do, I'll cut this portion. So see, I'll cut this portion from here. Okay, now I'll just make you visualize that the height will be x only. This much I'm going to cut from here also. Okay, now if I cut from here, this one and then this one, I'll just show for two. Now what we'll do, we fold this up like this. So you can see this was x and this become height. Here it was x, I'm folding up like this. Then from this side also. So height will be x. Then from this side also. So you will get the box, open box. So this will be height. This will be 18 minus 2x. This is also, if I cut this much, also 18 minus 2x. Got it? So these are the three dimensions. Okay. So what will be the volume here? Therefore volume would be product of these three. Volume equals to x into 18 minus 2x into 18 minus 2x. That is the whole square. Now what you want to do? You want this x. So question is this. We find x. This is a question such that the volume is maximum. Volume, let me call that as V. Volume V is maximum. That's what you are asked. Is it? The volume of the box is maximum. Okay. So now this is, as we did earlier, this much is only important, formation of the function in all remaining questions. Okay, so let that be a function fx. Fx equals to v equals to x into 18 minus 2x. What we'll do, we differentiate it how many times? Twice, because we want the maximum value. Okay, so I'll use the product rule. Here derivative is 1, 18 minus 2x the whole square as it is. Now x as it is. This is 2 times 18 minus 2x by chain rule into minus 2. Fine. Just differentiating once. Okay. You can take, I think, 18 minus 2x common. So here we are left with 18 minus 2x because you have square. This is how much? Minus 2 into 2 with minus sign, and x is there, minus 4x. So this is 18 minus 6x. Okay. Now we differentiate it one more time, f double dash x. Okay. So product rule, one term is this, the other term is this. 18 minus 2x as it is. What's the derivative of this? This is 0, this is minus 6. Okay, plus now 18 minus 6 as it is. What's the differentiation of this one? This is 0 and here you have minus 2. No need to simplify, you can leave it in this form because the value of this is not important. What we are going to do is, we are going to decide whether it is a positive or negative. Okay, now you know for maximum or minimum values, I'll write here maximum only because you are asked for maximum volume. So for maximum value, first order derivative is always 0, turning points. F dash x is 0. So we have 18 minus 2x into 18 minus 6x equals to 0. Fine. So obviously from these either x is 9 or here x is 3. These are the possible values. So there are two turning points, either 3 or 9. Now from this, one thing is quite obvious that this 9 is not possible. If I put 9 here, then see both length and breadth will be 0, 18 minus 18, right? So this is by observation, you can see this has to be less than, total length. Not possible. This is not possible. Why this is not possible? As then 18 minus 2x will be, 0. This is 0. That's why length or breadth cannot be 0. So 9 is not possible. Okay. So we have just 3 now. Okay, so x equals to 3. Now we checked whether at this place function has a maximum value or minimum value. So I'll find f double dash. What is f double dash? The first term here, if I put 3 there, so this is 18 minus 6, so 12 into minus 6. Plus, if I put again 3 there, so the second term is 0, I suppose. So this ultimately this is negative. Fine. It is actually minus 72 if you want to write. This is minus 72. This is negative. That means fx equals to v has maximum value. Why it has a maximum value? Because second order derivative is less than 0 and first order derivative at 3 already 0 because it was one of the turning point. Okay. So therefore what is your conclusion? X is equal to 3 is the point of maxima, and therefore you can write that is we remove how much 3 centimeter from each corner such that V is maximum, volume is maximum. That's conclude the solution. Fine? Clear? Not difficult. What is important? Formation of the function. Okay. Look at the next question. Question number 18. Okay. There instead of square you have a rectangular portion. So there is a rectangle here. Okay. I suppose it's copy of the previous one only. 45 and 24. This is 45, this is 24. Right? A box you are going to construct without top by cutting off square from each corner. So from each corner you are going to cut something. So we assume that we are going to cut x centimeter from each corner. So you are going to cut this and you will take it up, flap up. So this is nothing but x, this is also x. Here this is x, this is x. Here this is x and this is also x. You will cut this. So this will be the height. What will be this much? 45 minus 2x. What is this? 24, this much. 24 minus 2x. Fine. So I'll write let x centimeter to be cut off from each corner. As you wrote in the previous question. Okay, then what are the dimensions here? Therefore, I'll write dimensions are, or you can let me write, no problem, height, length, and breadth are, height will be x as I've shown there. You cut this and flap up, so this become height. This one will be 45 minus 2x. Why? X will be subtracted from this, and this is nothing but the 24 minus 2x. The earlier one, the previous one was a square. Here you have, what you have? Rectangular sheet. Okay. So therefore, volume V equals to x into 45 minus 2x into 24 minus 2x. Fine. Now this is a polynomial for you. Either you can keep this one as it is and you can do the differentiation. Let this be fx. Okay, what we want to do? Let me write that. We find, the question is, what's the question? How much should be cut off such that the volume of the box is maximum. So we find x such that V is maximum, such that V is maximum. I'm sure now you can do it. It's just the copy of the previous question. So I leave it for you. Do it. I'm sure you can do it. Flow of the solution is just the previous question. Okay. Now let's go to next question. Question number 19. What the question number 19 says? Show that the all rectangle inscribed in a given fixed circle. You are given a circle, and inside the circle, inscribed means what? Inside the circle you are going to put a rectangle. Okay, what you want to show? The square has a maximum area. That means if that rectangle has a maximum area, then it will be actually a square. That means you need to show that the length equals to breadth. Got it? I'll show the diagram so you'll understand. I repeat, what we are going to do? We are going to put a rectangle inside a circle. And at the end, we'll show that if the area is maximum, then that rectangle is actually a square. That's what we want to show. So here is a circle. Let radius equals to small r. Let radius equals to small r for the circle. Okay. Now we are going to put a rectangle inside this. Let's assume that this is a rectangle. Okay. So let me call this as ABCD. This be a rectangle. Width, length and breadth here. I'll take length as x and breadth as y. Okay. So this quadrilateral ABCD is a rectangle. With length equals to x and breadth equals to y. Okay. Fine. With L equals to x, this. Now you can just join these two. So obviously it will pass through the center. So this is R, this is R. Fine. Now what we want to do? Let me write here. We find, this is the question. Sorry, we don't want to find. We show here, we show that this is what you are asked. If area of this rectangle is maximum, area of rectangle is maximum, then it is a square. It is a square. So that means you need to show that x equals to y, length equals to breadth. And a rectangle, if length equals to breadth, then it becomes what? Square. So what we'll do? We here write area of this rectangle. So now we start with area of the rectangle. Now area of the rectangle equals to, let me write A equals to length into breadth. Area is this L into B. Now you need to reduce into a single variable. You cannot keep the mixed variable because you want to differentiate. So we need to get some relation. Now this is a right angle triangle, So in triangle, let me write for example BAD. You can use the Pythagoras Theorem. So this will be hypotenuse x square plus y square equals to RR. So 2r whole square, which is 4r square. Got it? That's a use of this circle actually. So now I can put the value of y here. What's the value of y in terms of x? So x into y would be root of 4r squared minus x squared. You have get the y from this, which is 4r squared minus x squared. Y is positive because it's a, what is that? Breadth. Okay, so you have this. Let this be fx. Now this is our function. Okay, so now sum is almost over. Formation of the function. You have formed the function. Now what we do? We'll show that x equals to y if this function attains the maximum value. That's a question now. Got it? Now I'm sure you can do it. Up to this you need to understand. If you are clear with the earlier, exercises. Fine. Now with how many times we are going to differentiate it? 2 times. Product rule. Differentiation of x1, this portion as it is, plus now x as it is, differentiation of this one. Imagine this as x. What's the derivative of root x? 1 upon 2 root x. 1 upon 2 root x. 4r square minus this one into, by chain rule, differentiation of this one, which is here r being constant because it's a radius, minus 2x. So this will get cancelled. So this will be 4r squared minus x squared. This is minus x squared upon 4r squared minus x squared. Fine. So here you just take the LCM. So this will be free from the square root. This x square and this x square gives us what? Minus 2x squared. Upon, this is your LCM, 4r squared minus x squared. This is f dash x. Simplification is must here because second derivative you need at this place. Okay, now we'll go for double derivative here. Differentiation of this f double dash. So I'll write f double dash here, which you can do here also, but let me do it for you. So square the denominator function, 4r square minus x square. Now here 4r square minus, this one as it is, 4r square with root. 4r square minus x square with root as it is. What's the derivative of numerator function? Just, you can see how much it is, minus 4x. Minus, now, here that numerator expression as it is. Which one? 4r square minus, 2x square as it is into differentiation of that root expression. Derivative of root x is 1 upon 2 root x. So we have this 2 into 4r squared minus x squared into, by chain rule, minus 2x. You know all these things very well. Just for you I'm doing. Okay, now we'll simplify. So this 2 will get cancelled. That root expression is multiplied with this. Okay, and this minus and this minus gives us plus. So what we'll get here? 4r square minus x square into minus 4x. This minus and this minus gives us plus 4r square minus 2x square into x, till that x is there. Okay, upon, after taking root, here 1 power and here half power. So 4r square minus x square raised to 3 by 2. Okay, now it's just a question of simplification over here. You can find x common and simplify. In fact, you can find 2 also common from this. So I'll take minus 2x common. And after the simplification, inside the bracket you will get 2 from here and 4 from here. So 6r square. And what about this? Here this will be 2 already taken common, x square, and I suppose it will be just x square over here. Right. Check it please. Upon 4r square minus x square raised to 3 by 2. I did for you double derivative. We required it. Okay. Now for maximum value, because you are asked for maximum area, for maximum value f dash x must be 0. Okay, so there just numerator expression will be 0. You put here equals to 0, take on the other side, so this much will be 0. So I'll get the 4r square minus 2x squared equals to 0. That root will go on the other side. So 2r squared is equal to x squared. right? R is a given radius. So what is x from this? Root 2r, right? X is always positive because it's a length, you know from the beginning. Okay. Now you put x equals to root 2r in the double derivative also, and you need to notice that that should be negative. F double dash root 2r, right? So this minus sign, x is root 2r, this is 2, so 2 root 2r, x squared will be 2r squared, so this will be 4r squared upon x squared will be 2r squared, so it will be 2r squared raised to 3 by 2. Everything is positive, but your minus sign in front of this, so this is negative, right? So what it says, when x is root 2r, then second order derivative is negative, first order derivative is 0. That means when x is this root 2r, then a function has maximum value. Function has maximum value. That is, area is maximum. Function was area. Just go back to beginning. What was the function? That is this one. And what was that? That was the area. That is, area of rectangle is maximum. Fine. Now if x is root 2r, therefore what is y? You have ready formula. Root 2 4r squared minus x squared. Put value of x squared here. So it will be 2r squared. So finally you will get the root 2r. And therefore x equals to y. And therefore it is a square. It is a square, not a rectangle. In the beginning you had not assumed that x equals to y. But if area of the rectangle is maximum, then you have actually x equals to y, right? And therefore it is a square. Fine. When the rectangle becomes square, if length equals to breadth, that's what you have shown here using the concept that the area is maximum. Okay. So 20th question, again good question. Show that the right circular cylinder, okay, so we have a cylinder here, closed cylinder. I'll show it, you know it. Okay, so suppose this is a cylinder here with height equals to h. This is a base here, which is circle. One more base on the other side here. This is a cylinder. Let the base radius this much equals to r. This is r. Let the height equals to h. This is height. Okay, fine. So we have such cylinder here. So let me write here. Let r equals to base radius for the cylinder. For you are given cylinder here, and h equals to height. You need to introduce the variables first in such questions. Randomly you cannot write. Okay, now what is given? Given surface. So we are given this. That means this is used to convert into single variable. Given surface, right? Here that is S. Now what is the surface area of this? You know, that is 2 bases area, pi r square, that is 2 pi r square, plus that lateral surface area. You know what is lateral surface area? 1 circumference of the circle multiplied with h, 2 pi r, that is circumference of this, and then goes to h height, so 2 pi r h. This is given, right? So we use this, call that as 1, to convert the function into a single variable. Now what is asked here? Okay, we keep inside right now. We are asked to prove. Yes, we prove because we are asked to prove here. So let me write that. What we want to prove? Show that whenever the maximum volume, so for maximum volume, so you are going to maximize volume. So volume is your function, right? For maximum volume, the height is nothing but what? Diameter of the base. Now I have chosen r as a radius, so 2r. This is what we want to prove. So at least from the beginning you know what you want to do. Fine. Volume should be maximized. Then you will show that you will get h is equal to 2r. Okay. So write the formula for volume. So what's the volume of the cylinder? Volume, let me call that as V here. What is that? Area of one circle taken up to h height. So you know it is pi r squared. Area of this taken up to h height. So pi r squared h. If it is cone, then it is just 1/3 of this. 1 by 3 pi r squared h. You know it. Okay. Now we want to maximize this function. So it should be converted into a single variable. From where? From 1, obviously. There is no other option here. In that circle question, you had used that Pythagoras theorem, and by that, x square plus y square equals to 4r square, you had converted into single one. Here, either you place the value of r from here, but at two different places you are r. So it's better to get h from this and place here. So it will be purely in which one? In r only, because s is given, means it's a constant. So v equals to pi r square. I'll write here by 1. What we are doing now? By 1 we just get the h. What is h from 1? So it will be s minus 2 pi r square. S is constant. Why it is constant? Because it's given. 2 constant, pi constant. You are going to differentiate in form of r here. R squared upon you have 2 pi r, which is h. Fine. What is h? I repeat. S minus 2 pi r square upon 2 pi r. I'll place here. So s minus 2 pi r square upon 2 pi r. You can see that this is purely in r now. In r here. So I'll call that as a what? You can write v. You can give v also, but I'll just write f of r. Let this be f of r. So what will get from this? See, pi will get cancelled. 1 r will get cancelled. So we are just getting r by 2. Here 2 and 1 r. S minus 2 pi r square. I'll just open this. Probably then the differentiation will be easy. S being constant as it is, by 2 as it is, r as it is. This 2 will get cancelled. You will get half pi r cube. This is a function of r. Okay, so we differentiate it with respect to r now. How many times? 2 times. F dash r. S by 2 being constant as it is. Why S by 2 is constant? Because you are given the surface. Given thing is always constant. This is just 1. You know this is 3 pi r square. Okay. So now one more time differentiation here. This being constant 0. This is minus 6 pi r. R being radius always positive, pi positive, 6 positive. So this is always negative. It means volume is always maximum. You are clear at this place only. Volume will attain the maximum value. That's obvious from here, because second order derivative is always, negative. So for maximum volume, first order derivative is always 0. So f dash r is 0 here. If f dash r is 0, place over here. So we'll get the s by 2 minus 3 pi r squared equals to 0. Fine. We are interested to find here what r. So we want r, remember. So r squared will be, what is r squared? Just make the r as a subject of the expression. So r square will be s by 6 pi. Fine? Clear? R square, sorry. And of course, if you can get a r from these also, and I'll write here f double dash r is negative, right? That means function will have maximum value. Okay. So when r square is this, first order derivative is 0, f double dash r is negative. So volume is maximum. Volume is maximum if r square equals to 6 by s by 6 pi. Okay, now what we do? We need to use the equation number 1. Okay, so by 1 here we use that h. What is h? That is nothing but s minus, you can just look at in one of the earlier expression, minus 2 pi square upon 2 pi r. Why I have used again this? Because I want to get h equals to 2r. So therefore h equals to, whenever the volume is maximum, then this is a relation. So I can place the value of s. What is s? That is 6 pi r squared. This we could find only when the volume is maximum, minus 2 pi r squared upon 2 pi r. So what is this? This is nothing but the 4 pi r squared upon 2 pi r. So it will be just, 2r. H equals to 2r. So and that's proved. That's what you want. Height equals to base radius. But when we could derive this under the condition that the volume is maximum? Just look at this. This comes from those two conditions. Second order derivative is less than 0 and the first order derivative equals to 0. Okay. Now let's go to question number 21 here. Next question. So here this question is more or less like the previous question. We have cylinder here. Okay. So let's take the base radius as r and height as h, as we have introduced. So for you are given the right circular cylinder. For cylinder here, base radius equals to, let's take r, and height as h. Okay. Now what is given? That is constant. That's equation number 1 for us. So we are given here, given that. So this become equation number 1 like the previous question. What's given? Given the volume of 100 cubic centimeter. Volume V, which is 100. Okay, 100 centimeter cube. But what's the formula for volume? 1 circle into h height. So pi r squared h equals to 100. Right? We call this as equation number 1 here. Call this as equation number 1. We'll use this as we did there because this is given to you. 100 pi r squared h. Okay. Now what you want to do here? So let me write that. So we keep in our mind we want this. We find, what we find here? We find the dimensions. Dimensions means what? R and H. We find R and H such that, satisfying which condition? Such that surface area should be minimum. Such that minimum surface area. Surface area. I hope now this is clear to you what you want to do. You want to get R and H for which the surface area is minimum. Previous question was more or less opposite. There you were given the surface area, you had some condition on the volume. Here volume you are given. Okay, so let's write the surface area. Surface area, that is S, equals to, as you did in the previous case, 2 circles, so 2 pi r squared, and that lateral surface area which is circumference 2 pi r of h height, r square because you have 2 circles, this surface area, and pi r squared h height. Okay, now we want to minimize this function. Okay, so you have double variables here, r and h. This will not do, so you need to place you need to convert into the single one. So what we'll do, the one way is either you can place the value of r or you can place the value of h. The choice is yours. But here h occurs one time. So from which equation? 2 pi r square as it is, 2 pi r as it is here. I'm just putting the value of h from 1. So by 1. Why we are doing this? This should be clear to you. There h is 100 by pi r square, I want to convert into a single variable. Okay, so this will be 100 by pi r square. Clear? Okay, so 2 pi r square as it is here. Let me simplify. Pi will get cancelled, 1 r will get cancelled. So we'll get the 200 by r. This is purely function of r, you can see. So I'll call that as f of r, which is surface area with the given condition. Now we want to minimize this function. So now our usual standard technique. Differentiate it how many times? 2 times. 4 pi r minus 200 by r squared. You know differentiation very well. What's the derivative of 1 by r? Minus 1 by r squared. What's the derivative of 1 by x? Minus 1 by x squared. So we have this. Differentiating with respect to r. Again differentiation, f double dash r. 4 pi being constant as it is, here 1. Differentiation of this one, you know, this 2 will be in the product, and this is 400 by r cube. You know derivative of 1 by r squared, which is minus 2 by r cube. Right? All these things are very elementary for you now. So minus minus will be plus, and you have this. Okay, what we'll do now, for minimum value or surface area, f dash r must be 0. First order derivative must be 0. So let's put this equals to 0. So what we'll get here? 4 pi r minus 200 by r squared equals to 0. Okay, so here I'll take LCM. 4, you can divide by 4 also. 4 pi r cube minus 200 equals to 0. Dividing by 4. So pi r cube equals to how much? 50. So what is r? We want dimensions. That is the questions. R and h. So what is r? It will be 50 by pi raised to 1 by 3. Okay? If r is this, you need to notice that if r is this, the double order derivative must be here positive, because you want to minimize. Also f double dash r for this everything is positive here. This is positive, r being radius is positive. So this is always positive, you know. Right? This is very clear. For any value of r, it's positive, because r being base radius, it is always positive. So this is positive. So therefore, that surface area, which is fr, attains minimum value. Minimum value. If r is this, if r is 50 by pi raised to 1 by 3. Okay, you want h also. From where you will get the h? Now you know you have this. What is the h here? For h you have this prepared formula, right? Put the value of r over here. So you will get the radius and as well as what? The height, right? For h you have this 100 by pi square. Use that. I'll just write now. Use h equals to 100 by pi r square formula. Okay, place this, so you'll get the value of h also in centimeter. Right, height will be in the centimeter, base radius also in centimeter. Fine, this much you can do. Okay, so let's go to next question. 20. Next one is which one? 22. Yes, let's see that. So now you must have realized after doing 5 questions what we are doing basically. A wire of length 28 meter is to be cut into 2 pieces. One piece is to be made into square form and the other one is in form of circle. Okay. So there is a wire of length 28 meter. You are converting into 2. One is in form of what? Square, and the other one is in form of what? You know, here circle. Fine. What's the question? What should be the length of these 2 pieces? Okay. Such that the area of the square and the circle is minimum. Fine. Okay. So here we start like this. So you are converting one in form of square. These are the 2 objects. The other one is in form of circle. Fine. Okay. So one piece is used to form this. Okay. You know perimeter. That is perimeter. And the other piece is used to form what? Circumference. You know circumference also, 2 pi r. Fine. So I'll start with like this here. Let one piece, here 2 pieces you are doing now. Let one piece length equals to x. Okay. Total wire length is how much? Total wire length is how much? 28 meter. Okay. So therefore second piece would be, obviously now you know, length has to be how much? 28 minus x. Okay, clear? What is asked to get the lengths of these two pieces? Once I get x, immediately I can get the 28 minus x. Okay, this everything is in meter, it is understood. Okay, fine. Now one piece is used to form a square here. The other one is used to form what? Circle. Okay, I want the area of this. So I need what here? Measures of the two sides. Now what is this x? X is a parameter. Right? So perimeter, if I take 4p, then 4p equals to x. So what's the length of each side? So for square, measure of each side, obviously it would be how much? It has to be, it's very obvious, x by 4, x by 4, x by 4, x by 4, x by 4. So you will get the x, total perimeter. This much meter is used to form the square, total perimeter. Okay, let me write here this. For, for circle, the 28 minus x is used to form this perimeter. So for circle, perimeter, 2 pi r equals to 28 minus x. Where what is r? That's the radius of the circle. Fine? Got it? R is the radius. Okay. So you will get the r from this. Why we are getting r? Why we are trying for r? Why we have obtained one side? Because ultimately we are interested in area of both of this. So 28 minus x by how much? 2 pi. This is radius, here measure of each side. Right? So therefore here you want to maximize or minimize function as the area of this. So area of square plus area of what? Area of circle here. What is area of the square? This into this. How much? That is nothing but side square indirectly. It is nothing but how much? X square by 16 plus what's the area of the circle? Pi r square. But what is r? That is 28 minus x by how much? 2 pi the whole square. Okay, this is your function, sum of areas here. Okay, equals to this, equals to we have this. Okay, now here you can see it is purely in form of x, pi constant, 28 constant. But before I do further, I'll just simplify. This is 4 pi r squared. So 1 pi will get cancelled. So it is just 1 by 4 pi 28 minus x the whole square. I'll call that as a function fx because it is in form of x. Okay. Now I'll not do. What we want to do, that I'll write just for you. What is the question here? We find these two things, lengths of these two pieces. That is, we find x. Once you get x, immediately you will get the 28 minus. We find x such that the sum of the areas, that is f of x, is what? Maximum, minimum. Okay, this much you can do now after doing so many questions. This must be minimum. So what you will do, you differentiate this 2 times, even not a big task. 1 by 16 is constant, just 2x by 16, this is constant, use the chain rule and get the value of x by putting the first order derivative equals to 0. So for you, continue further. I hope up to this you are clear. Up to this it is important, formation of the function. X square by 16 plus 1 by 4 pi as it is, 28 minus x the whole square. Okay, chalo. Next question now, 23, third question here, 23rd question. What it says, prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 of the volume of the sphere. Okay, so what you are going to do, inside the sphere you are going to put what? Cone. Inside the sphere you are going to put the cone, yes, and we'll show this. Okay, so let me draw the diagram first here. So we have a sphere here, so let me draw the sphere. This is a 3D picture, so it's little bit difficult to visualize. With the center O, the radius of this one is given here. Given r equals to radius of the sphere. This is given, radius of this sphere. Okay. Now what we'll do? Now inside this we put a circular cone here. So I'll just show like this over here. I'm putting a cone inside this. Okay, so let's see, this is a cone inside this. This is a base. So base is a circle like this. Okay, I've placed cone inside this. Okay, now we take the base radius of this here. This is the base radius as a small r, and height as a, for example, h here. This is the height. This is the height of the cone. Okay, and this is base radius. Fine. So let h equals to height of the cone. Fine. And r equals to base radius. Base radius. That we have introduced. Okay. Fine. Now see here. What is this? From center of the sphere to, this is one point on the sphere. If I join this is r, big R, radius of the sphere. Right. What is this? This is center of the sphere. This is one point on the sphere. So if I join this is the radius. If I consider this is always perpendicular. So this will be a right angle triangle. It would be a right angle triangle. I'll call this as, for example, M. This is O, and let me call this as A. So AMO is a right angle triangle. Okay. Now see, this we have taken as H. Look at here. This I have taken as H. What is this? Can you just tell me? What is this portion? This much. One point on the sphere and center of the sphere. So this is R. Total is H. So can you tell me OM? What is OM? The OM is nothing but what? H minus big R. Okay. So I'll repeat this. See, this is total height of the cone. Total height of the cone. One point and the center of the sphere. This is big R. This is big R, radius of the sphere, center and one point in the sphere. So if I want to get this much, because I want to form the right angle triangle. So if I just look at this much, that is total H minus radius. Okay. So in right triangle, AMO, you have OM equals to H minus R. Okay, that the other things are obvious here. This is, small r, radius of the cone, base radius. Okay, so therefore by Pythagoras we have hypotenuse square equals to, you have r square plus this much, that is h minus r the whole square. Okay, by Pythagoras theorem, by Pythagoras theorem. Okay, this is very, very important point here. Okay, let me expand this. So r square equals to small r square, h square minus 2rh. This is treated as a constant because it's given. This we have defined, that means they are variables, plus big R square. So this will get cancelled. So you can make the R square as a subject of the expression here. So 2RH minus H square. This is as per our discussion. This is 1. This is the relation between H and R. This big R is a constant. So that's not important for us. Fine. Okay. Now what you want to do, that I'll write. So we show this is what you are asked. We write so you can understand, or you can keep in your mind. Show that what you want to show. The radius R is 8 by 27. Okay, let me read the entire question. So we'll show that here volume of cone, that's what you want to show. Volume of cone is equals to what you want to show here, that is equals to 8 times no, not 8 times, 8 by 27 times volume of sphere. Volume of sphere. Volume of sphere. When you want to show this you want to show. But when you want to show this, if you read the question, you will realize you want to show this. But when, see the question carefully. Volume of the largest cone, right? Volume of that, this you will show when volume of what cone is largest. Is largest means what? It attains the maximum value. Understood? Volume of what? Cone. When the volume of cone attains the maximum value, then volume of cone is 8 by 27 times the volume of sphere. So you are going to maximize which function? Volume of cone. And at the end we are going to derive this. Okay, this should be clear to you. So we start with now what? Volume of a cone. Okay, so what's the formula for volume of a cone that is inside this sphere? Volume of cone. Why we start from this? Because you are asked in this way. Equals to, 1 upon 3 pi r square h. That you know very well. Okay, we did it twice. Okay, now you cannot keep this double variable here. Either you need to place the value of r square or h. Here r square is ready for you. So it is 2 big R h minus h square into h. From where? By 1. Okay, why we did this? To convert into a single variable. So 1 upon 3 pi constant, 2r constant, this is h square minus h cube. Okay, this is the volume of a cone. It is purely in h, so I'll take that as f of h. We want to maximize this one. So how many times you are going to differentiate it? Twice. Okay, now as usual, now you are almost through. F dash h. 1 upon 3 pi outside as it is. 2r being constant. R is given, that means it's treated the constant. This is 2h minus 3h square. One more time, f double dash h, which is 1 upon 3 into pi. What about this? 4r constant as it is. This is just 1 minus 6h. Fine. 4r derivative of h with respect to h1. This is 6h. Okay. Now we write for maximum value of f function, its derivative must be 0 for turning point. Okay, so I'll put this much equals to 0. 1 upon 3 pi, you can take on the other side. This is 4rh minus 3h square equals to 0. Fine, got it? So here this will be on the other side. You can take one more h common. So 4r minus 3h equals to 0. This is height, so this never be 0. So this must be 0. So what will be h from this? 4r by 3, right? This h never be 0. Height cannot be 0. So this much must be 0 and therefore this. Okay, right? And over here also, what is important one you need to show? At this place, double derivative must be f double dash 4r by 3. You want maximum value, no? So this should be negative. So 1 upon 3 pi as it is, 4r as it is, minus, when I put h equals to this much, 6 is already there, 6 into 4r by how much? 3? Okay. So what is this? This is, 12, and here you have 4. So this is 4, this is 12. So from this we have here, we have the negative value. Okay, so double derivative is negative. At this place the first order derivative is 0. Therefore f of h equals to volume of cone is what? Negative means is maximum or the largest, right? If this is arch equals to 4r by 3. That was the important conclusion. Okay, now we'll come to that point, right? We relate that. What will relate? The maximum volume of cone. So we are going to put this one where? In the formula of the volume of the cone. So therefore maximum volume of cone equals to, in which one? This one. Here you are going to place. You are going to place the value of what? You are going to place the value of, r square and h both, because you want the information in form of big R. So 1/3 pi r square. What is r square? That you know, right? 1/3 pi r square. From where this r square? Look at it 1. You can just write because of 1. This is by 1. 2rh minus h squared. What? 1/3 pi r square h. H is this. Now in turn you need to put again the value of h here. Let me just rewrite here. This is 4/9 pi into r. I'll keep as it is. 2r. What is h here? That is 4r/3 minus, what is this? If I place the value of r, 16r squared by 9. Fine. Just placing this value of h, for which the volume of the cone is maximum. Now we just simplify this. 4/9 pi r as it is. Here simplification. So it is 24r square by 9 minus 16r square by 9. So we'll have 4/9 pi r. What about this? From this you have 8r square by 9. Okay, and let's simplify it further. If we just simplify this further, from this you have here 4/9 into 8/9 into pi r square. Okay, pi r cube, sorry, pi r cube. You have r into r square, that is pi r cube. Now I'll just set here as per our requirement. What you want? You want 4/27. You need 8/27. So 8 here. I'll take 3 from here by 27. So 4/3 from here into pi r cube. What is this? This is just rearrange as per our proof. This is volume of sphere. Right. What was this? This was the maximum volume of cone, largest volume of cone, and therefore truth. So it's such a nice question. Diagram was the only crucial point here. Okay, so in the 24th question we have here the cone like this. This is more or less the question number. I'll just tell you the number. This is more or less question number 20th. You can just compare with 20th. More or less like that question only. There you have shown that the height equals to diameter of the base. Here what you want to show? You want to show that altitude equals to √2 times the base radius. So it's like that only. Okay, I'll do it at least up to the formation of the function. So this is height of the cone here, height h. This is base radius, which will take the small r here. Okay, you can take this as O, for example A, and you can take B here. Fine. So for cone, for right circular cone here, h equals to height and r equals to radius, base radius. Now what is given here? Given volume. Okay, so volume of the cone you are given. What's given? Given V equals to volume of the cone. Volume of cone. What's the volume of cone? 1/3 pi r squared h. So V is constant. This is our equation number 1. We'll use this, V is given means this is a constant. Either we place r square or h in the formation of the function. Now what you want to prove, that I'll write here. We are asked to show, so you can understand at least what we are asked to show. show that the right circular cone of the least curved surface area. So when surface area is minimum for the cone, least means minimum, then what you want to prove, and given volume, so this is given to you, has an altitude, that is h, then you want to prove this. When minimum surface area is then show that equals to root 2 times base radius. So this is what we keep in our mind. So which function you want to minimize? Surface area is minimum, so immediately we'll get this. Okay, and in surface area we'll use this because v is given. Okay, so surface area here, surface area of this cone equals to, you know, pi r l. What is that L? Slant height, you know, right? Where L is, you know very well, that is slant height. Right? All these things you already done earlier in 10th standard. Okay, but L you can place in terms of h and r very easily. So I'll write here what I'm going to write. You can just write, you know, s equals to pi r root of, by Pythagoras, h square plus r square. This equals to, if you want here, L square equals to h square plus r square. Okay, now just for our convenience I'll square it and I'll form s squared as a function. This is just for our convenience, s squared, because whenever, you know, s is minimum, then h squared is also minimum, into h square plus r square. Fine. And I'll what I'll do, I'll take here. Okay, anyway, now the question is you reduce either in h or r using what? Equation number 1. That's what we want to do now. So by 1, obviously you should place the value of what? R square, because r square occurs twice here. So by 1, what is r square? The r square would be 3v by, you know, pi h. Look at it 1, you will see this. We place here. Why we are doing this? To convert into a single function, you know very well now. Pi square as it is, here 3v by pi h, 3v by pi h, and then here this h square as it is. And what about this r square? That is 3v by pi h. Fine? Clear? Just placing the value of this. You can take this as a, now it is purely in h, so let's take this as f of h, that is s squared. Why I've squared this, you know, just make it free from the square root. So here 3v, 1 pi will get cancelled, pi, 3v pi by h, this is h squared plus 3v upon pi h. Okay, fine. So this is our function. Now you need to differentiate it how many times? 2 times. If you want, you can take that h inside probably. So 3v pi I'll keep as it is. Before I differentiate, I should do this. So this is the h, 3v pi as it is, into 1 by h squared. Okay, let me differentiate it 2 times. Actually now almost solution is over. For your convenience, I'm just differentiating this 3v pi being constant as it is. Differentiation of h with respect to h is 1. Here 3v pi being constant as it is, volume is given, that's why we are keeping as a constant. You know, this is minus 2 by h cube, 2 by h cube. Fine? Okay, again double derivative, 3v pi as it is, 0 here, here minus, this is 6v pi. What about this? Minus 3 upon h raised to 4. This is h raised to minus 3, you know. And what's the derivative of h raised to minus 3? You know, minus 3 h raised to minus 4. So I wrote directly minus 3 by raised to 4. This is minus minus will be plus. So 3v pi. This will be plus 6 3s are 18 v pi into h raised to 4. Now here everything is positive, volume positive, pi you can cancel. The important one which we notice here is double derivative is here, double derivative is positive. That means surface area must be minimum. Fine. Okay, so therefore here f of h, which is here h square, and you can write hence s is minimum here, hence h is minimum if what first order derivative is 0. So actually this I should do in the beginning, but anyway, if f dash h is 0, okay, first order derivative is 0, so put derivative equals to 0. This is constant, so we are having just this much, 3v pi, you do in detail, upon 2 by h cube equals to 0. We want what here? What you want here? You want what you want to prove? You want to prove h equals to root 2 r. So we are interested to find h here. So get h here. What is h from this? Okay. So we write 1 equals to 3v pi into, I'll write here 6, 1 by h cube. Okay. So h cube equals to 6 by pi into v. We are getting this much here. So now we put the value of, obviously, v, 6 by pi as it is. What's the volume here? You know from the beginning, from the equation 1 upon 3 pi r square h. Pi will get cancelled. This is 2. 1h will get cancelled. So after the simplification, you are getting h square equals to, h square is equal to how much? You are getting 2 r square. Just simplify, you will get this much only. And therefore h equals to root 2r, right? H is always positive, so you cannot have negative. So therefore proved. When we are getting this, if S surface area attains its minimum value. Actually this you should do in the beginning here, but anyway I did it over here, so proved.